Welcome to today's lecture, my dear students. Today, in the last class, we have done the double integrals with constant limits. Now, today's lecture, I am going to do the double integrals with variable limits. What is meant by the term variable limits here? So, in the integral, suppose we will define the double integral and the function f of x comma y, and we define this as with respect to x dx and with respect to y dy. And let us say, now first whenever we are writing the integration with respect to x we are doing, so this is the integral which is of the for the x. So now the limits of x is with a variable limit and the limit of y is a constant limit. Okay, the outermost integral, that means with respect to y when you are doing, that becomes the outermost, and this limits will be the constant limits. Okay, and the one which you are doing with respect to x, that is what from the function x is equal to y1 to x is equal to y2. This is what the variable limits. So first we will be solving the innermost integral with respect to x and substitute the limits from y1 to y2, and then integrating with respect to y, and then we'll substitute the limits from a to b. So this is what the finding out the working procedure to find out the double integral with the variable limits. Let us solve one problem to understand this concept. For example, if the question is asked that evaluate integral 0 to pi, integral 0 to x, x sine y dy dx. This is the question. Now, first y is dy, so we are going to integrate with respect to y. And the limits of y are 0 to x. This is what you have to understand. In the question, they will not give what is x and what is y. So, first you have to write down what are the limits. So, the limits are what now? Y is ranging from 0 to y is equal to x. And the limits of x are the constant limits ranging from 0 to pi. So, this is what the understanding of the limits. Now, what is the first thing you do as we have done with the constant limits? Same way, do first the bracket. Try to solve this whole integral how we have done for integration. The single integral how you have done. Same procedure. The only thing is here, there is a function. Now, with respect to y you are doing, so there is a variable x. So whatever x or whatever the other than y variable you have, you are going to send it outside of the integration. If you are integrating with respect to x and there is some y term, you will send y to the outside of the integration. Now, how to evaluate this? Let us rewrite this. Integral 0 to pi. Take x outside of the integration and start integrating 0 to x sine y dy. And then start integrating with respect to y first in the innermost integral. So what it gives you? Integral 0 to pi x times of, what is integral sine y? It is minus cosine y from the limit 0 to x dx. So what is your understanding here is, in the place of y, you are substituting the upper limit minus the lower limit. Let us see that. Integral 0 to pi. I will take this negative sign outside. First, whenever you have some negative sign inside, if you take it out, then it will be easy for you not to do the mistakes. So now terms of cosine of upper limit is x minus cosine 0 dx. Now it is negative integral 0 to pi x times of cosine x. Now negative of negative, it is positive. Integral 0 to pi x times of, what is the value of cosine 0? Cosine 0 value is 1. So it is x dx, x into 1 dx, which is this x into cosine x into cosine 0, which is x. So, okay. So, now let us solve this integral. Let me call this as first I1 and I2. Try to understand this properly. So, to get this, what is I1? I1 is integral 0 to pi x times of cosine x. So, how to do this procedure of integration is by using the Bernoulli's method, because there is an algebraic function here. u is x and dv is cosine x. Now what is the derivative of x? 1. The derivative of 1, 0. Integral of cosine x is sin x. Integral of sin x is negative cosine x. So now we are going to multiply this with this and this with this and then using the signs. So let us now do the calculation here. So it is x times of sin x. So I'll go to the next page. Your I1 is given by x times of sin x minus 1 times of minus cosine x, right? So x times of sin x times of sin x minus 1 times of minus cosine x, that is within the limits 0 to pi. Let us apply the limits here now. It is pi times of sin pi minus of minus plus cosine pi, upper limit is over, minus the lower limit 0 times of sin 0 plus cosine 0. Now always sin pi is 0, so pi is also, pi times of 0 is 0 and cosine pi value is minus 1 and then minus this is 0 and cosine 0 is 1. So the value of this is minus 2. So I1 is given by minus 2. Now what is I2? Let us write down. I2 is what? It is integral of x dx within the limit 0 to pi. So this is integral of x dx within the limit 0 to pi. And this you know, normal into x square over 2 within the limit 0 to pi. Now apply the upper limit. It is my pi square over 2. So this is what the second integral. So let us now come back to our integration process here. What it is my equation is 1. The value of the integral is this one now, correct? So let us now go to this equation. So let us call this as 1. So from 1 it is negative of the I1 plus I2. So therefore the solution is negative of I1 plus I2 and we have got that I1 is negative 2, so it is, and I2 is this, correct? It is negative of negative 2 plus pi square over 2, so that is 2 plus pi square by 2. So this is the method of solving a double integral with variable limits. I hope you could understand it properly. So let us now to do one more problem to make you to understand. For example, we have a question of this type. Integral of 0 to 3 and integral 0 to root y. It is x cube times of e raised to 2y dx dy. This is what the question. So what we do now is first write down the limits. The limits are here. The limits of, first what are the limits? We are going to do with respect to x. So these are the limits of x. So the limits of x limits are from 0 to root y and y limits are from 0 to 3. So first you have to identify the limits and then start putting the bracket here. So you are going to do the integration with respect to x. Now when I am doing with respect to x, this is the term which consists of y. So you have to send this particular function e power 2y. This you are going to do. You have to send this to outside of the integration. Okay. So let us now solve this problem. So that gives you integral of 0 to 3. Now take e raised to 2y outside of the integration. Integral 0 to root y and this is x cube dx and then dy. Close the bracket and then dy. I hope it's clear. Now what is it? It is integral of 0 to 3 e raised to 2y times of integral x cube is what? X power 4 by 4 within the limit 0 to root y dy. Right? So now let us apply the upper limit and the lower limit. It is e raised to 2y. I'll take this by 4 outside, okay, 1 by 4. This 4 I will take it outside 1 by 4. And let us write down the upper, substitute the limits. So root y the whole power 4 minus 0, which is dy. Clear? And now what is this? This is 1 by 4 times of integral 0 to 3 e power 2y times of root y the whole power 4 is y square dy. Now all of you know how to solve this integral. This is just of the type integration by parts, correct? Integral 0 to 3, I will write this as y square times of e power 2y dy. So this is what the way. So now how to solve this integral? This is by using the Bernoulli's method. So let us take y square as u and dv as e power 2y. Right. Now I'll just give a little gap and then do it. So dv is given by e raised to 2y. Now let us find the derivative of y square 2y. Derivative of 2y is 2. Derivative of 2 is 0. E raised to 2y integral is e raised to 2y over 2. Its integral e raised to 2y over 4. Its integral e raised to 2y over 8. Okay. So now what we do? Just take the products. These products to get the solution. So now what is the value here? It is y square times of e raised to 2y over 2. Then 2y times of e raised to 2y over 4. The next term is 2 times of e raised to 2y over 8. See, the terms are y square into e raised to 2y over 2. This is the one. 2y into e raised to 2y by 4. This is the one. Then 2 into this one. Now what you are going to do? Put the signs. Plus first, next minus, next plus. Now let us do the calculations a bit. 2 1s, 2 2s and 2 4s, let us say. And now I can take what is the limits now. So what is the solution now? The solution is, it is 1 over 4 times of this function is what? 1 over 4 times of this e raised to 2y. Can I take common? Yes, right? In every term I have e raised to 2y. I'll take it out. And then y square by 2 minus y by 2 plus 1 over 4. Now the limits are from 0 to 3. Just apply the limits to get the solution. And now that gives you, it is 1 over 4. I'll just take the copy of this and let us do that in the next page. Okay. So this is what the value here. So now let us solve the substitute the limits. So it is 1 over 4 times of, first I am applying the upper limit, which is e raised to 3y times of 3 square by 2 minus 3 by 2 plus 1 over 4. Upper limit is over. Minus lower limit e raised to 0 times of 0 minus 0 plus 1 over 4. So when it is 0, please don't leave like that, because every time the value of 0, when you put here, you will not get 0 every time. So it is 2y, means 2 into 3 it is, I'm sorry. It is 2 times of 3, which is 6. So it is e raised to 6 times of, it is 9 minus 3. 6 by 2 means 3. 3 plus 1 by 4, which is 13 over 4 minus e raised to 0 is 1. 1 into 1 by 4 is 1 by 4. You can keep it as it is, no problem. So this is what the solution of the double integration of the variable limits, the method to solve is this. I hope you could understand. With this, we have completed the double integration with the constant limits in the previous lecture, with variable limits in this lecture.